Hey class, Mr. Houston here back again to talk to you about some more right triangle things. Today we're going to be talking about what's known as the tangent ratio. There are three trigonomic functions that we will be talking about, sine, cosine, and tangent. Today we're going to be talking just about the tangent ratio. So here's what the tangent ratio means. Alright, so if we have a right triangle, and we're talking in perspective to angle A, we need to identify the leg opposite of A, which is this green one over here, and the leg adjacent to A, which is this blue one here, and then we always know which one the hypotenuse is. So the tangent ratio is always opposite over adjacent. So even though we're not into it just yet, like I said before, we have sine. If I can write sine, we have cosine, and we have tangent. I don't know if you guys have heard this little thing, but there's a saying to remember these. It's called SOHCAHTOA. So, S-O-H, Ka, C-A-H, and then TOA, T-O-A. And what this means is the legs that we're talking about. So tangent is opposite over adjacent. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. We're going to be focusing strictly on tangent today and talking about opposite over adjacent. Okay? So let's kind of just put that into perspective here. Let's take a look at example number 1. We're going to find the tangent ratios. And whenever they say the tangent ratios, what they're talking about here is they want you to find the tangent ratios of R and of S. Okay? So let's start with the tangent of R. The first thing when dealing with tangents is, again, you have to identify your opposite leg and your adjacent leg. Opposite is always going to be the one that is across from the angle you're talking about. So in this case, 18 is our opposite. Adjacent is the one we always touch that isn't the hypotenuse. So our adjacent is 80. So when we are finding the tangent of R, again, it is opposite over adjacent. We would do 18. I think I can write a better 8 than that. 18 over 80. And yes, you will want to simplify that down. You could say it's 9 over 40. And let's also give a decimal approximation of it, and it would be 0.23. That would be the tangent of R. Then we're going to go back and we're going to find the tangent of S. So again, the tangent of S and the tangent of R will never be the same unless the sides are the same, because we have to identify our opposite, which again is going to be across from the angle. This time it's going to be 80, and then the adjacent side is always the one that it's touching that isn't the hypotenuse, which is 18. So this again, opposite over adjacent, which would be 80 over 18. Which when we simplify it down, we'll do that again down to an improper fraction of 40 over 9, which would give us somewhere in the ballpark of 4.44. Okay? So that is all that we have to do with that right there, is just simply figure out which one is the opposite, which one is the adjacent, and simplify those fractions down. Okay? All right, so now they're going to ask us to find the leg length when one of them is missing. Okay, so anytime you have a degree in there, we are going to use this as our angle for tangent. Just remember, tangent again just simply means that we are doing opposite over adjacent. So in this case, we are actually going to use the tangent of 32 degrees is equal to opposite, which is 11, over adjacent, which is x. So now we have to solve for this. We need to get x by itself, but because x is on the bottom, we have to multiply both sides by x. And what that's going to give us is x times the tangent of 32 equal to 11. Then we'll divide by tangent of 32 divide by tangent of 32. And in your calculator, you will hit there, you'll see a sine, cosine, and tangent button, and you will just do 11 divided by the tangent of 32, which will give us an approximation of roughly 17.6. 17.6, and you can round it right there. So if we were looking to find all sides of this triangle, you now could find the hypotenuse by using Pythagorean theorem. But that's how you would figure out, now we can figure out a side length as long as we have one angle measure and one side measure. Okay? Alright, let's take a look here at the last example, example number 3. Again, we are trying to find the height of the lamppost, which is right here. We have, let's see if I can find a better color that might show up a little better there. We'll see. Alright, so again, we have our angle measure. We identify this as our opposite. This is our adjacent. So we would say the tangent of 70 is equal to opposite, which is our h, over adjacent, which is 40. Now in this case, again, we're trying to get h by itself, so we're going to multiply both sides by 40. Again, in your calculator, because there's no good way to just kind of memorize tangents, we'll say the tangent of 70 times 40 will give us 109.9, and in this case they asked us for the height to the nearest inch, so we will say h is equal to 110 inches. Okay, so the main goal of this lesson is for you to understand the trigonomic function of tangent, and that tangent is always going to be equal to the opposite leg over the adjacent leg. That's the main goal for just tangent. The next lesson we'll talk about sine and cosine. So just make sure that you understand that when we are trying to find opposite over adjacent, it's always from the angle that we are dealing with. Okay, so you'll never have like this angle here, opposite over adjacent wouldn't be the same as if we were doing it over here. Okay, so that's it for today. If you have any questions, please bring them with you to class, and we will see you then.